Modeling periodic behavior. The sine and cosine functions are both referred to as sinusoidal functions. This means they can be used to model many periodic functions in the real world, such as the movement of hands on a clock or the temperature throughout the day. Now, before we do some modeling problems, let's talk about how to find the min and max of any sine or cosine functions. So here we have state the minimum and maximum values of this function here. So let's look at what a sine function is. If you look at a basic sine function, like y equals sine x, start at 1, goes up and comes back down, yada yada. The max would be the amplitude. And we can tell the amplitude by the number in front of our system here. So 1, so 1. Our min will be the negative amplitude but going down. So -1 will be our min. So in a normal sine function, your max is the amp, your min is the negative amp. What if we do it a little more complicated than that? If we have a vertical shift, well, in that case, you start at the 2, the vertical shift, and then you go up, down, yada yada. So what's the farthest you go up? Well, the amp. In this case, that'd be 1, so 3. And the farthest you go down would be the negative amp, or amp going down, sorry, which is 1. So my max would be here, and my min would be there. So all the vertical shift does is move their whole graph up or down the vertical shift value. So if you notice how to find the max here, well, you start at the vertical shift, and then you just go up the amp or down the amp. And that's how we find our max or min. On a sine or cosine function, we want to find the max. Let's get the vertical shift and add the amp. And to get the min, we'll get the vertical shift and we'll subtract the amp. By the way, vertical shift is also known as principal axis. Right? Where's your middle of the graph? So you can also consider it that. So look at the problem we're doing. Right? If I wanted to find the max on this one, first, you look what's our principal axis or vertical shift, and right here to -3. That's where we're starting. So we're starting at -3, and all we gotta do is add the amp, which is 5. So to get 2, sending for the min. Right, where's my graph starting? It's starting at -3, the principal axis, and then we're gonna subtract the amp. So -5 is -8. So 2 would be my max, negative would be the min. And if you actually want to look at the graph, right, the graph will start at -3, then you go up 5 and down 5. So it would have been up to 2 and down to -8. So that's how it looks, and that's the easiest way to find the min or max of a graph. Now let's move on to how to actually model some information. So the average daytime temperature for a city is given by the function d of t equals 5 cosine 5 pi over 6t plus 20 degrees, where t is the time in month after January. Sketch a graph of d against t for 0 to 24. So they want us to sketch this graph. So d against t. So let's say this is t and this is d, 0. Quick cut, so you don't have to bore you with me drawing the graph, but I decided to go by 2's for the time and go by 5's for the temperature, for average temperature. So now let's graph this. So remember the way we graph a cosine function, we always like start the vertical shift, so we start with 20. So this is my principal axis. Then we look at the amp. Amp is 5, so that's the highest I'm going to go, is 5 above that, so 25 will be the highest my graph goes. And then 5 down would be 15, so that's the lowest my graph goes. I gotta find the period, how long it takes to repeat itself. So period equals 2 pi over b. My b in this case is right here. That's my a for the amp. So 2 pi over pi over 6. That's saying 2 pi divided by pi over 6, also known as 2 pi times the reciprocal. So 12. So it repeats every 12. So if we're doing it, this is a cosine graph, so that means we're going to start at the edge here. Right, start at 0, and I'm going to end at 12. About there. Halfway would be 6 is my lowest. Halfway between these two would be 3, so around there. Not the one time counted by 2 hurts me. And then halfway would be 9. So that's what my graph's going to look like. And I probably should fill out the graph. So 12 plus another period would be 24, another 12. 12 plus 12 would be 24. So, and right there. Whoops. And right there. Halfway would be 18. Halfway between that would be like right there and right there. So this is my graph. So there we go. Find the average daytime temperature of May. So now so we just gotta find May and plug it in or look at our graph. Now here's where it's a little tricky. It says they want T to be a month after January, right? So January, T's month after January. So January is actually 0. February is 1. March is 2. April is 3. And May is actually 4 in this case, not 5 like normally, because they wanted it to count after January. So a little annoying. But here's 4, right? So I go up there. Oh, that's going to suck. So this didn't end nicely, so it means I actually got to plug 4 into, we substitute 4 into our equation there. So let's do that instead. I was hoping we could just look at the time, like over here, if it was 6, it's 15, right? If it's 2, it's about 20. But let's sub it in. So we're going to find d of 4, so we're just going to plug that in. 5 cosine pi over 6 times 4 plus 20. This is the same thing as saying 4 over 6, so 2/3, 2 pi over 3. So 5 cosine 2 pi over 3 plus 20. Cosine 2 pi over 3, that's over here, it's 60 degrees. We're at 3, 1, 2. So it's 1/2, negative 1/2, oh, sorry. 5 times a negative 1/2 plus 20. Negative 2.5 plus 20. So 17.5. That's the average temperature in May. And you couldn't see that because I always do that. I am sorry. Anyway, that's the average temperature of May. Find the minimum average daily temperature and what month does it occur in. Well, look at our graph here, right? So minimum average daily temperature is right here. So it looks like it occurs in month 6. With our messed up system, would be April, May, June, July would be 6, right? June would be 5, and July would be 6. So that's the lowest temperature, minimum average temperature. That's weird. Anyway, we could also go around again. Another 12 months would be right here. Looks about 18, right? 18 minus 6 is 12. That's a full year, so it would be July again. So find the average minimum daily temperature and what in the month it's in. So average minimum daily temperature would be 15, and it happens in July. Okay, next problem. On a hot summer day in Madrid, Antonio pays careful attention to the temperature. The maximum occurs at 41.8 degrees Celsius at 3:30 p.m. The minimum occurs at 27.5 degrees Celsius. So there's just sine functions that can model the temperature for that day. So we want a sine function for that. I always like to personally picture it a little bit. So I'm going to draw a little bit of a graph. The max is 41.8 and the min, doesn't really matter, 27.5. Little thing, the max occurs at 3:30. So if we're talking about like military time, that'd be what, 12 plus 3:30, 3.5, so about 15.5 is where the max. And if we're looking at a basic sine function, right, a basic sine function starts in the middle, goes up, comes back down again. So I'm just using this for an example to approximate. It looks something like that. Let's say that's the max, that's the min. So my max should happen at about 15.5. Now, if we're gonna model a sine function, we want to come up with a sine equation. We have to start with the basic one, which is y equals a sine b x minus c plus d, right? Where a is the amplitude, b is the period, c and d are your horizontal shift or your phase shift, and your vertical shift. Now, when we start this, it's always easy to find the d, the vertical shift. So how do we find that? Well, that's just the middle. So how do you find the middle of anything? You add up the max and the min, and you divide by 2. Right, so that's where our middle is. So we're going to add 41.8 plus 27.5, and we're going to divide that by 2 to get 34.65. I use a calculator for that, by the way. So 34.65 is our middle, so that goes here. So always the easiest thing to find first. So next, what do I find after that? Well, then for me it's really easy to find the amplitude. I just get my max or my min, and it's subtracted from the middle, or the vertical shift. So now I know this is 34.65. All I gotta do is subtract 41.8 minus 34.65. I could do this one live. That's 5. That's a 7. So 1, and that would be 7. So 7.15 is my amp. Right. So again, for me, the key is always all about finding the middle. If you find the middle, then it makes finding the amp super easy. Now, to find the middle, just take the max and the min, divide by 2. Get your middle. Now to find the amp, you just subtract this final distance between those two, or the bottom two. You got those. Next is a period. Period always works the same, or next is b, sorry. And that always works the same way. If you want to find b, you got to remember that the period equals 2 pi over b. So you got to think, what's the period here? Well, we're talking about a hot summer day. So by default, our period is going to be 24 hours. Because we're talking about hours in a day. So I'll make this 24, set equal to 2 pi over b, and then just do some math. So 24b equals 2 pi, divide by 24. B equals pi over 12. So that is my b. So one last thing. I got to figure out what my c is. Now, if you have a graph already, c is actually really easy. It's just, where does your graph kind of start the middle at? Like, where is this point at? Where does your graph start? Now, in this case, I actually don't have a middle. So it's not as nice. So how are we going to do this one? Well, this one takes a little logic. From here to here is 24. Right, so our full period is 24. Well, what's the halfway mark then? That would only be 12. Alright, so from here to 24, that's about 12. Oh, so all of this from here to here is 12. So that makes that from here to here is only 6. Right, because it's halfway of 12. And that makes from here to here is only 6. See what I'm putting out there? Right, the whole thing's 24. Halfway would be 12, which means, I probably should have on this side, this half would be 12. Well, I could cut that up in 2. That means this is 6 and this is 6. Why am I doing that? Because I know where this point is. That's at 15.5. If I go 6 back, it's going to be where I start. So it's going to be 15.5 minus 6, or 9.5. That's where we're starting. That's where this graph is starting out at, 9.5. We'll start in first period. So 9.5. That's my equation. Y equals 7.15 sine of pi over 12 x minus 9.5 plus 34.65. Again, we're going to do another one of these, but that's the general idea. Anytime I have to model a sine or cosine function, I always start with the middle. And how you do that, max plus min divided by 2. Once I find the middle, all I gotta do is find the amplitude. So you just subtract the max from the min, max from the middle, or the middle from the min. Then you gotta work with the period. How do you find the period? You gotta figure out what the period is. Either look at the graph itself, or they'll tell you somewhere in the problem, and then you just set that equal to 2 pi over b. And then in this case, this was actually tricky. Most of the time, when you have a graph like we do next, it's probably one of the easier problems. But in this case, since it was a little tricky and I have a start, I had to think about logically. A full period is 24 in this case. So I know halfway is 12. Well, if I know this point is, that's 15.5. Then since this whole thing is 12, these must be 6 and 6. So go 6 back, and you got 9.5. Okay, let's do another one of these. The monthly temperatures for Cape Town, South Africa are shown below. So January, February, March, blah, blah, blah. We want to model data for a trig function using the following formula. Where January is 1, February is 2, thank goodness, January is 1. Draw a scatter diagram for the data. So I'll do that off camera. And here I go. I decided to go 1 to 10, and then I did a little cheat thing where you kind of skip a lot of letters and go 5 to 28. It was kind of a hassle. Feel free to pause any time to catch up. But there's a scatter diagram. So that's A. B. Without using technology, estimate BADC. So we're talking about this right here. So again, A is the amp, B is the period, C is a horizontal shift, and D is a vertical shift. Now they have in this form, you can go any way you want. I like to start with D. I like to find that middle. Now the thing with this problem, we're modeling, so it's not gonna be perfect. It's gonna be an estimation no matter how you do it. So let's talk about how to find the middle here. So I'm gonna find my max and my min divided by 2. Now there's really no max here, there's no min there. I'm gonna use the min here as 15. And the max, so in this period you actually have 28 and 26. You don't have to use the actual max, it's just an estimation. Either one's fine. I'll do 28 because it's kind of where we start. So to find my D, I'm gonna do 28 plus 15 divided by 2. 28 plus 15 is 43, divided by 2 is 22.5. So that is my middle. I always like to kind of draw it so I know what I'm talking about. Again, this is all this estimation. It's not perfect. It's about there. Right, and then from there, I like to find my amplitude. Because all I gotta do, again, you can go from this to the top or this to the bottom. It's just a estimation, so it's not gonna matter either way. But since I use 28, I'll use that with the 22.5. So my A is gonna be 28 minus 22.5, which would be 5.5. So that's my A. Okay, now to find the B. So this one's probably the one that's the least of an estimate. So we have to figure out what our period is. Now if you look at this, that looks like one full rotation. So it took about a full year or 12 months. So to find my B here, we're going to use 12 months as our period. Period equals 2 pi over B, and our period is going to be 12. So 12 equals 2 pi over B. And again, all we do here is just cross multiply and solve. 12b equals 2 pi, divide by 12, and b equals pi over 6. So that is my B. And then one last thing we got to find our C. Now a lot of this has to do with what type of graph that we want. In this case, it's a sine graph, right? Straight out, they want a sine graph. So remember the way sine graphs look, right? Sine graph. Ooh, I don't need that. Sine graph start at the middle, go up. Look at our graph here. Where would a sine graph start? This is all going down, so it's not there, and then goes up again. So somewhere around here. So if we want to estimate it, it looks like about 10, right? What's my middle? About 22. Look on this graph here. Where's about 22? So about 10. You could say 10.5. Again, it's just an estimation. There's no wrong answer. Well, there's no. If you say 27, you're wrong, but around there's no wrong answer. You could say 21.22, 22.5. So it's somewhere around. Oops, sorry, 10, 10.5. Somewhere around there is where the middle should happen. And again, it's a sine graph, so it should be going up. That's why this one right here doesn't work. This is exactly 22, but the values are going down. That's here. Sine graph should be going up, so around there. So we could say 10, 10.5. I'll probably just say 10.5. We'll say C is 10.5. And there's our equation. Y equals A, 5.5, sine of pi over 6, T minus 10.5 plus 22.5. As always. So we have that. Now they want to check our answers using technology. So let's bring some technology in. Let's talk about how to do that. And so to finish this video, we're going to use a calculator. Let's show you how to do it. So let's type in all our data. So remember, if we want to type it in, you turn it on. I'm gonna go stat and edit, and I'm gonna put for L1. I'll put the months. Now I'm gonna put January. I'm gonna put 1, 2, 3 all the way to 12, and then for temperature I'll put the temperature. I'll do this off camera. Okay, all typed in. So next, let's graph this. So remember I typed in by putting stat edit. So now I want to plot this data. So I'm gonna go stat plot right there. It's in blue. So I'll put second y equals. Now notice these are your stat plots. I want to turn one of them on. So press enter to get to the first one, and you got to press enter to turn it on. Now we're doing it. So this is the type of graph you want. Now we're doing a scatter plot, so that one's fine. I'm just gonna scroll down. L1, L2, mark. That's all good. Hit enter, and then we're gonna hit graph, and you can't see anything. That's because our window's off. This graph right now is going from -10 to 10, -10 to 10. Look at my data right here. It's going from 1 to 12, and it's going from like 28 all the way down to 15. So there's two ways to fix this. If you want to fix it by hand, you go to window. Okay, what's the X-min? Well, the lowest I see is 1. I mean, I can put 0 so it gives a little buffer. Highest I got was 12. I'll go to 13, same idea. Let's give ourselves a little buffer. 1, 1. Scale is what you want to count by. You just default it to 1. The the Y-min. Now, the lowest I hear is 15. Again, I'll just probably go look to 12 just so I can see a little better. And the max I see is 28. I'll just go to 30. So I could have a nice little view. Then I'm going to hit graph. See, now you see your data. Right, so I did a pretty good job. So how do we check our data? We're going to type this into our equation also. We're going to graph that. So I'm going to go to, well, actually I didn't talk about the other way to do it. So that's the way to do it by hand, how to manually fix your window. If you want to fix it a little easier, you just go to zoom, and they give you all these zoom options. And one of them down here is zoom stat. That tries to fit the window for your statistics, for your data. So hit enter, and you can see it's about the same. They adjusted a little bit more. Anyway, now let's talk about how to check our answers using technology. So we're gonna type this into our calculator. So I'm gonna go y equals, and we're just gonna type that in. 5.5 sine pi over 6. So there's pi's right here. Oh, caret, second caret. There you go. Divided by 6. Parentheses. T. Now I don't have a t, we just use x. That's the rule of the calculator. Just use x. Minus 10.5. Close it. Close parentheses. Very important. Close parentheses. Plus 22.5. Now, actually, before I graph this, I forgot one thing. When we graph sine and cosine, you generally want to be in radians. So make sure I'm in radians mode. It is in radians, so that should be good. I hit graph, and it's in populator data. Any moment now. Any moment now. And I messed up. What did I mess up on? I didn't close the parenthesis again. Notice how they actually open up two parentheses, one for sine itself, and then one for when I did the after the pi over 6. So I should have two closed parentheses. I didn't, so I included 22.5. That's why my graph was way off. So after all that talk about how important parentheses are, I messed it up. Anyway, put the second parenthesis. Now it should be fine. Now I hit graph, and now you see it's actually popping a lot faster. So we get a graph like that. So again, if you look at it, pretty good. We're good right here. We're good right there. This little part's a little messy, but that's what's expected to happen. Now again, we're doing this by hand, so it's not going to be perfect, but it's a pretty good model of that graph. That's it.